Today, using data and automation technology, operator finesse or performance, or perhaps even somewhat just plain old experience, is becoming less critical to producing quality projects in better time and closer to or even better than budget. The great news is that repeatability and improved results are happening today with the implementation of automation in construction. Modern day life has changed. Where once landline telephones and calling cards were used, we now rely heavily on connection to people and information through cell phones, smartphones, and tablets with apps. Manual estimations, measurements, and staking has migrated to using laser levels, wire mesh renderings, and GPS drones and rovers. For vehicles and equipment, analog sensors have evolved to digital and local area networks, wireless, satellite, and cellular telematics reporting technologies, autonomous vehicles, and haul systems. Today, we are connected more than ever before, real time, and can make real time decisions and changes. We need repeatability, reliability, and accountability. Engine emissions have driven many developments in the equipment industry. In conjunction with engine design, communication between components has also evolved. From mechanical fuel pumps to electronically controlled unit injectors capable of multiple injections throughout the combustion cycle, these controls yield improved fuel economy, higher horsepower, improved matching of engine and transmission and hydraulics for increased performance and fuel productivity efficiency. Other improved technology applications, such as ultracapacitors, has opened the door to hybrid machines, not just cars, but also excavators and electric drive machines. Construction machines have evolved and continue to evolve, but aside from engine emissions, a great deal of technology has been developed and implemented in large-scale operations in the mining world where safety requirements are strict and fractions of a percentage point improvement have large and faster payback. Enter autonomous haulage systems. It is interesting to note that driverless cars and on-highway trucks are still making their case for implementation, when in fact, autonomous haulage has been in commercial use, not just trials, in the mining industry for over a decade, 13 years in fact. But it began much earlier with Komatsu testing in Japan as early as 1990. Consistency, predictability, and long-term planning of mine sites has allowed the use of autonomous haulage, driverless haul trucks. With more than 150 machines right here in Canada, these mighty machines haul 300 to 400 tons per truck, eliminating errors and inconsistencies without human detriments. Simply through implementation, sites experience an immediate 15+% improvement in reliability due to eliminating operator error in addition to increased production. While we are not ready for complete autonomous implementation with construction equipment just yet, advances in technology are accelerating and began with machine control in motor graders, dozers, and now semi-automatic grading in excavators. Let's leave the autonomous haul trucks behind for now and look at other ways automated technologies can influence what we do. Let's take a moment to discuss some basic advantages realized when implementing grade control systems. First, conventional grading. This relies heavily on the human element. Experience definitely helps. Unfortunately, hand-eye coordination leaves room for improvement, especially between grade stakes, and even with well-seasoned operators. As a result, there is typically planned rework. This rework adds to extra wear and tear on a machine, increases fuel costs, and takes longer. You can probably guess that the addition of automated grading reduces the dependency on the human element and need for experience. Work performed is consistently more accurate over the entire application, which significantly reduces rework and thereby lowers wear and tear, reduces fuel, and speeds completions. With the addition of automated grading, there is an overall measurable improvement due to better use of assets, reduced, not eliminated costs of surveying, and lower material costs. Improved company performance adds to competitiveness, attracts new talent to the workplace, and helps bridge the experience gap. Existing operators perform better and are less strained by the end of the day. And improved results can improve the overall company image. A key differentiator in capability and application can be described with the terms 2D and 3D. For 2D, think elevation only, one point at a time. With no location relative to the position on a job site, there is need to re-establish a reference point, zero, or rebench at each new location or application. For simple planes where grade does not change over large areas, lasers can accomplish one or two surfaces but still needs regular checks. Lasers used for correction require line of sight. Without lasers, more reference points, for example grade stakes, need to be established. Creating more different slopes requires changing the setup for each new situation, but complex contours cannot easily be accomplished with only 2D systems. So what difference does 3D make? Think GPS. Location on the job site is known, the horizontal reference, as well as the required elevation, vertical reference, at each location. For complex contours or jobs with multiple grades, 3D is a clear winner. Simply put, 2D is simple, flat surfaces. 3D can do everything 2D can, plus more complex contours. It is GPS referenced across the entire job without the need to constantly re-establish a reference point. Understanding the conventional grading process provides a basis for understanding why 3D machine control is necessary for anyone to remain competitive. Without knowing the location of design features and required grade on the job site, the operator is solely dependent on grade stakes. These only provide a small picture of the entire job site, and grading between stakes is still at risk for inaccuracy. Many times, this takes multiple passes and many restakes before final grade is achieved. Even a very skilled operator is challenged to keep accuracy at the blade within a tenth of a foot, or about the size of a golf ball. It goes without saying that the more material you move, the more cost you incur. It is best to move only as much as required. So, what if we introduce more consistency to the construction job site? How can we achieve 1/10 of a foot accuracy consistently across the entire job site? Enter grade control. With 3D grade control provisions, the plan can now be placed in the hands of the operator. A display shows where the machine is located on the proposed job site, as well as the entire site around the machine. Work around the job site is quickly determined for the day and where the site either needs fill material or needs stripping. With location on the job site known, stakes are no longer needed to show feature locations or proposed grade. The machine is capable of cutting to grade more accurately than before and thus substantially cuts down the time needed to complete a project. 3D grade control began with motor graders and has migrated to dozers, but what has become conventional grade control is good for finishing grade only. Enter intelligent machine control. This dozer is fitted with machine control. Can you tell? It looks as though some things we might be used to seeing are missing. This is IMC, Intelligent Machine Control, the next machine evolution, a truly integrated machine. IMC provides even more instant returns. Every operator can achieve better results like they have many more years of experience and maximize machine performance, not only on-grade performance. So what makes intelligent machine control the way of the future? Integration. Integration is much more than simply factory-installed mounting points, harnesses, hydraulic hoses, and valves to complete a grade control system. As a start, an integrated machine incorporates sensors to eliminate external harnesses that aftermarket systems cannot avoid. No cables, connections, or climbing is necessary since no components are installed or removed at either end of the workday. There are benefits to pre-wired machines, but the difference is intelligent machine control integrates with the main machine to maximize overall machine capabilities and performance, and therefore maximizes production and improves finished product, much more than simply finish grading. This first truly integrated dozer appeared on the market in 2013. What does intelligent integration do? In combination with integrated sensors, in 2013, Komatsu developed the first operator-selectable dozing modes. These dozing modes optimize the dozer for various applications and load types to achieve maximum production, even used long before reaching finished grade. These modes allow for the integrated machine to engage automatic blade operation without operator interaction from rough cut all the way through to the final finish pass, first pass to last pass. Traditional aftermarket systems or factory-installed machines cannot engage automatic blade control until approximately half a foot from the target surface. In short, this means maximum blade load for each pass from the beginning of the job provides maximum material movement and more utilization of the machine automated controls. How does intelligent machine control compare to grade control systems? Much of the advantages of conventional grade control systems are applicable: reduced staking, improved grading, but intelligent machine control goes further, reducing the passes and time before the finishing pass. A quick review. Going beyond grade control to intelligent machine control means using assets more effectively through automation in more applications. It's been said that humans have prospered because of two main capabilities tied to vision, both physically seeing danger and also vision to anticipate the future. In the next evolution of an intelligent machine control, we in effect give a dozer eyes. By knowing the contours of the surface ahead of the machine, it can anticipate and proactively adjust the blade as it encounters the contour, rather than waiting to feel the load increase, then making adjustments. Knowing the contours of each step of the job can improve consistency as the job progresses. Consider backfilling, where specific lifts are needed to achieve compaction specifications. Conventional grade control would simply operate at finish grade and fill in batches or need to be manually overridden by the operator. Manual, not automatic. With proactive dozing controls, lifts can be pre-programmed and reference the existing surface to achieve consistent lifts while still matching the finished design as subsequent passes are completed. Fewer overall passes, consistent, repeatable results, and less rework using the automatic controls, much more. Automation continues to evolve even aside from managing finish grade and increasing production. By expanding the integrated machine control technology, additional inputs, aside from simple steering, assist dozer direction control while dozing. In this example of a new feature now available in the marketplace, the tilt steering function automates blade control, reducing operator input in order to maintain straight travel, all while protecting the finished grade surface. Up to this point, we have looked primarily at automation advancements in one machine, the dozer. Until recently, excavator grade related technology had been underutilized and not accepted widely, mainly due to the lack of automation. Light bar style indicate systems would assist an operator in poor visibility or blind situations, or where other equipment could not be used but lacked the response and performance needed to make substantial payback without a lot of operator skill and patience. In 2014, a significant change occurred in excavator grading technology, the addition of semi-automatic grade assistance. Here is an illustration of how automatic control, automatics, prevents over-excavation. Called auto stop. When lowering the boom, automatic control takes over, stopping the boom lowering to prevent any further digging. Similarly, when curling the bucket, auto stop automatically stops the bucket curling action to prevent further digging. Preventing over excavation is good, but what can be better? Auto grade assist. In auto grade assist mode, semi-automatics assist the operator by automatically raising the boom to maintain grade, all while the operator has full control of the arm and bucket functions. This function assists or complements the operator's natural digging and grading movements and prevents over-excavation rather than restricting operator controls. The result? The target surface is protected from the entire bucket profile, making a smooth, undisturbed bottom. Less rework, less compaction, and less fill material required with accurate grades saves time, labor, and material costs. Let's begin to look at how 3D excavator automation technology is applied. Do you see opportunities to improve in today's processes? Grade stakes add time and cost. Broken stakes add delays and increase cost. Each check requires additional time and personnel. Similar to intelligent dozers, 3D intelligent excavators can be freed from grade stakes. Accurate grade control not only increases accurate production, but reduces the need for in-the-trench checking when grading with confidence. Having seen how finished grade can be protected and achieved, here is a simple, significant advantage when automation is applied to the real world. Simple calculations for even 1/10 of 1 foot over excavation multiplied by material cost to fill that over excavation adds up very quickly. This valuation also does not consider extra time and/or delays for extra deliveries or additional site considerations such as logistics and restrictions. Understanding a little more about how the semi-auto grade controls work in an excavator, let's look at a couple of applications to make use of this automation. One might assume that a digital design file would be required for every step when automated systems are used. Quite the contrary. Even when working with existing structures, a 3D machine control excavator can be quickly and easily inserted into the job. Here is an example of connecting two structures, an existing to a proposed. In just a couple of steps while in the machine, The operator can add a simple design profile from the existing structure to the next with the required consistent slope. How can construction time be improved further, even aside from reduced staking? Technology assists the operator in additional ways when combined with automation. For digging a pit or a trench, total time is reduced by both actual production improvement as well as setup and inspection time. Aligning a machine accurately to the trench line without need for repeated staking and additional maneuvering improves setup as well as accuracy for the trench bottom and wall construction. Bucket lines extend for visibility and also restricts excavation outside the trench design, keeping alignment and reducing over-excavation. Using technology, processes can be further improved. The trench bottom is excavated according to design with no excess removal. No backfill or compaction or extra bedding materials are required to fill in gaps. Placing bedding materials with precision lifts that parallel the trench bottom further improves overall integrity, consistency, and optimizes material use. Lastly, imagine using the excavator to not only complete the excavation, preset 1, bedding material placement, preset 2, but as an additional check on pipe position accuracy, preset 3. Cycling through these presets speeds transitions between each job step with repeatable accuracy. Real-world studies have shown improvements in production and efficiencies through the addition of technology and assisted automation systems. These systems offer new capabilities and ways of performing job functions that go beyond simply machine utilization and production improvements. New applications are being discovered and implemented. These new applications can not only increase competitiveness for typical jobs, but may also open the door for new opportunities for niche work. Some applications are off limits to personnel, even in machines. For those situations, remote-controlled machines are being used, like this dozer, in an area where a slide could occur. Combined with integrated intelligent machine control, the operator does not need the feel of the seat in order to maximize productivity, because the integrated machine optimizes performance. With future job planning, it could very well be feasible to automate dozing actions and more. Automation considers not just equipment solutions, but also digital solutions. A 20% improvement using machines does not equate to a 20% improvement for the entire project. Digital solutions also impact outcomes. Digital opportunities exist to improve office processes and communication to and from the field, including retrieving as-built data for progress reports throughout the entire job and communicating design updates remotely, directly to machines and personnel. Each step of these processes can be digitized and therefore transforms the entire project and management. Even before going to the job site, planning, including bidding, has a significant impact on outcomes. Using a drone to survey a job site pre-bid can provide valuable details that may not be included or estimates may not be as accurate. Analyzing and communicating data to and from and combining with intelligent machines and other GPS hardware reduces surprises and augments processes. Captured as-built data from machines and inspections completes and verifies results for compliance and accountability. New best practices are developed and repeated for consistent results. So what's next? We have seen that automation has expanded in both dozers and excavators. More original equipment manufacturers will increase deeper integration with their products. We have seen that real, as-built production data is available for the gathering and is beginning to flow to the office for processing. With more real-time data, decisions can be made and problems can be solved faster. In the longer term, the outlook points to the Internet of Things and implementing 5G wireless networks. Higher wireless speeds and increased GPS signals will increase accuracy and enable movement away from local base station correction requirements. And, as technology advances, cutting-edge systems will become even more affordable over time.